As the Devonian period gave way to the Mississippian about 345 million years ago, much of North America was occupied by a shallow epicontinental sea. Beneath the waves of this shallow sea, from the far west, where the Grand Canyon would someday form, to the Appalachian Basin, stretched a carbonate shelf where great thicknesses of limestone were deposited. The limestones of the Appalachian Basin, later folded and in some cases faulted, would someday form some of the low ridges of today's Valley and Ridge province, just east of the Cumberland Plateau. The appearance and rapid spread of forests on land and the sequestration of a great deal of carbon in the limestones of these carbonate platforms led to a plummet in the amount of atmospheric carbon dioxide. This in turn led to a cooling of world climate and the reappearance of icehouse conditions as an ice cap once again occupied the South Pole. Icehouse conditions pertained and the South Polar ice cap existed for about the next 90 million years, or until near the end of the Paleozoic era, 250 million years ago. Another dramatic change as a result of the appearance and rapid spread of great forests was the phenomenal rise in atmospheric oxygen. During the Devonian, it had been lower than 15% of the total atmosphere, but during the Mississippian and Pennsylvanian, it rose to over 30%. The high oxygen content of the atmosphere, a bit over 300 million years ago, may or may not have had a profound influence on the nature of life on Earth. It depends on who you talk with. More on that later, but let's get back to the geology. The east coast of ancient North America had already, during the Paleozoic era, experienced two dramatic episodes of mountain building. It was about to experience a third, and the greatest, as the continent of Gondwanaland approached from the south. A bit over 320 million years ago, as Gondwanaland approached from the south, the Appalachian Basin and the adjacent carbonate platform began to fold and downwarp. And as time went by, the limestones were overlain by grayish and dark carbonaceous shales washed out of the rising highlands to the east. As the youthful Appalachian Mountains continued to rise, great deltas were formed to the west of the rising highlands, eventually being deposited on top of the shallow marine gray shales of the late Mississippian. These deltas eventually formed a vast, low, swampy, alluvial plain, heavily forested, where much of the world's coal deposits were eventually formed. And in these great coal swamps, some of the most astonishing creatures the world has ever seen existed. The Pennsylvanian period gave way to the Permian about 290 million years ago, and the Appalachian Mountains continued to rise. As folding and squeezing of the sedimentary rocks of the old Appalachian Basin intensified, zones of weaknesses formed in the rocks, and many gave way. Great thrust faults were formed, and huge fault blocks were pushed north and west. As the Appalachians were pushed ever higher, younger sedimentary rocks were eroded away, and in the east, where deformation of the rocks was most intense, the very cores of earlier, more ancient mountain chains were exposed, and these igneous and metamorphic rocks are today known as the Blue Ridge. By the end of the Paleozoic era, about 250 million years ago, the formation of the Appalachian Mountains and the supercontinent of Pangaea were complete. Well, that's the story of the formation of the Appalachian Mountains. But the story doesn't end there. Join me next time as Pangaea starts tearing itself apart and the gaudy young Appalachians erode into a sedate middle age.